Right, so in this example, here we're given the Ksp value, and then they're asking for the solubility. So that's going to be moles per liter. So different kind of information. We're going to go through it kind of backwards, but similarly to the ice table and using that X as your solubility. So initially, you just have water and solid copper iodate. It's going to dissolve into the following equation. So you have copper plus 2 ions and 2 IO3 minus ions. Those are aqueous. Those are going to be in our Ksp expression. So we usually write that right after, raised to the power of their coefficients. Again, always remember you actually include the charges in the brackets there. So to find the solubility, we're really looking for X. That's going to be our solubility. But we have to find the equilibrium concentrations of those 2 ions first. So like I said, if we think about a nice chart, we have initial concentrations, we know what our change is going to be, or we can figure that out, and then we know that we want equilibrium concentrations. So we're really looking for X in that ice chart. Um, these coefficients are going to change what our formula is going to be. So when I say that, I mean that since X is going to be in moles per liter, you're producing 1 mole of Cu plus 2 and 2 moles of IO3 minus. So the fact that those coefficients are there and they're not just a 1-to-1 mole ratio does make our math a little bit different. You'll see that in a second. So when we think about kind of like an ice chart or how our initial goes to equilibrium, copper is going to go from 0 to X, iodate is going to go from 0 to 2X. When we then plug in those expressions to the Ksp expression, so now we have X and 2X, um, all we're going to do is take the value that they gave us, set that equal to our Ksp expression, which now we have numbers and X's, so we're going to solve for X. So we're just going to simplify that. So make sure you take for squaring something, that inside, what's inside that parenthesis has to be squared properly and then distribute the x from outside. So 2x squared is really, do this just in case we forgot, is really 2x times 2x. So that's going to be 4x squared. But then after you distribute that x, that's how they get the 4x cubed. Okay, so in case we forgot some algebra. Let me just erase this out of the way. All right, so now what we're doing is taking that 4x cubed and we're setting it equal to 1.4 times 10 to the negative 7, solving for x. X is our solubility. So cube root, divide by 4, you're going to get 3.3 times 10 to the negative 3 moles per liter. So your answer is that x